Good morning, everybody, and welcome to Math with Mr. W. This is our thought for the day. Today's thought is Pascal's triangle. Blaise Pascal, French mathematician about 400 years ago, maybe a little more longer, I don't know. But Blaise Pascal, great mathematician, spent a lot of his life studying theology, but most of his life was theology, but he did so much in mathematics before he turned to theology. So part of that was this little array of numbers, which we call Pascal's triangle. It talks about how many choices, how many choices do we have? So let's talk about this row right here, the fifth row. Let's say you have 5 items to choose from, and let's say you could buy 2 of them. You're not sure about which ones you're going to buy, but you could afford 2 of them. You're not sure, okay? Now, we go start right over here with this 1. This 1 means that you didn't take any of them. After all the decisions in your mind, you decided, I'm walking away, I'm not doing a thing. So, that was my choice. It was a choice. I didn't do anything. Now, I had 5 items in front of me. I had 5 different choices. I could take one of them. So, if I took one of them, I have 5 different ways. There are 5 different choices, A, B, C, D, and E. But now, what if I wanted 2 of them? I really decided I wanted 2 of them. How many choices would I have? Well, I'd have 10. That's what this triangle tells me. I'd have 10 different possible choices. Now our brain up there knows this, even if it doesn't know Pascal's triangle. And sometimes when we have too many choices, we am going back to the 1 because it's too conflicting. So it's a great set of numbers to let us know that sometimes in life, our choices are way too big. But I've written this thing down to the 10th row. And I've done that for exactly one reason. Back and throughout the grades, we've been doing a problem about decreasing numbers. How many decreasing numbers are there? And a decreasing number is a number that looks like this. Let's say 5, 4, 3, 0. Each digit in the number is smaller than the one to its left. And so our question is, how many are there? And the first one we know is 10. And the last possible one would have to start with 9 and then go down to 0. So we'd have 9,876,543,210. And so that would be the one that's over here. The one number that we can write using all the digits. Now, when we started the problem out, we were back in, I think, 2nd or 3rd grade. And when we asked the question, all I asked the students was, how many do I have that are 2 digits? How many are there that are 2 digits? So when we figured that out, they figured out there were 45 of them. We don't worry about 1 digit because 1 digit doesn't make any sense. You can't have a decreasing number that's got 1 digit because it doesn't make sense. So the first decreasing numbers are starting here with 45 of them. And then the next year we did it again, but we talked about the 3-digit numbers. And we got 120. And then we moved to the 4-digit numbers, and we found there were 210. Now, I'm not sure if we actually got the answer for the 5-digit numbers, but that was 256. Now, isn't this beautiful? This is amazing. Now, things get a little crowded after the 5-digit numbers. And things start to go back the other direction. And as we end up seeing, the sum of this row, 45 through 1, is the sum of all these numbers, is the total sum of the decreasing numbers that are possible. So this triangle tells me my answer. It's written right here inside the triangle. It's written right here inside the triangle. And it's a beautiful set of numbers. It has so many other things that are in it that you may want to show your children in your classes, depending on their level of ability. So remember, we had something raised to the 0 power is 1. Okay. Well, what's 2 to the 0 then is 1, right? Well, what's 2 to the first? It's 2, isn't it? Well, the sum of these numbers is 2. That works out pretty nice. Well, what's 2 squared? Well, it's 4, right? Okay. Well, if we add up these numbers here, we get 4. 2 to the third is 8. And that's the sum of these numbers. 2 to the fourth is 16. That's the sum of these numbers. 2 to the fifth is these numbers, 32, 64, 128, and so on. So the sum of this row, if I added all the numbers, is 2 to the 10th, 1024. So you can use Pascal's triangle as part of your class. There are a great many different ways of using it because it talks about how many. There's ways of using it in problems dealing with probability that I know your children will enjoy. It'll give them some highlights into mathematics that perhaps they would never have seen. And look at this also. What's 11 to the 0 power? That's 1, isn't it? 11 to the first is 11. Let's read the next row. What's 11 squared? 121. That's son of a gun. What's 11 to the third power? It's 1,331. 11 to the fourth power is 14,641. And now you're going to go, well, hey, I'm going to have to do something here. Yeah, because on the next row, you've got some 2-digit numbers, huh? Well, that's okay because we got a 1 and a 5. Now we got a 10. So we're going to put the 0. I'm going to take the 1 and add it over here. Make that 11. That's going to keep a 1 and add this over, make it 6. So we have 161,151. Pascal's triangle. It's beautiful. Have a great day, folks. Have fun using this. I'll see you next time on Math with Mr. W.